In one of our previous videos, we created our database, ZTM. All that was left to do was put data in it, right? And you're right. All that's left to do is put data in it. And we went on a tangent that kind of focused on roles and permissions and data types, and we steered away from the core of practicality, but it is to give you that foundation of knowledge that you need before you dig too deeply into all of these commands and things that you can do. And the reason for that is, well, we could teach you all of these commands and we could show you how to create things, but it doesn't really bode well for a foundation. So we wanted to really hone in on that theoretical side and kind of give that base. And then from there, we can go ahead and create a bunch of data. Now, I promise we have to hold up for a second and we have to think about, what do we put in? Because I said in the previous video, well, let's go ahead and create some tables. But hold up. What are we going to create? What kind of table are we going to create? What are we trying to do here? Right? We have a database, but now that we have a database, what are we going to do with it? That takes some forethought, right? You need to think about it. You need to create maybe a model of some sort, and you would be right. We would have to create something called a database model. Usually before we create a database, before we get into the nitty-gritty of the practicality, we usually end up creating a model. What's a model? What does that do for us? Can I just go in and hack my way through creating tables and creating all of this crazy stuff and just figure it out as I go along and change things? You could. You definitely could. But a model would help you think ahead up front and not have to make as many changes as you go along. A little bit of thinking ahead will take you way farther. And so what I mean by that is, a model is a design that is used to visualize what we are going to build. And that is extremely important. We want to know what we're going to build before we build it, because if we don't put a little bit of thought into it, things are going to change and shift so often. Your database is going to be a moving target, and all of the software that may potentially be built against it, or all of the queries you write against it, they're continuously going to have to change. So we're going to have to think about it before we build it. This is what we would call an entity relationship diagram. It denotes what exactly we are going to build. Now, what do I mean by entity relationship diagram? Well, if we look at what we're trying to build, we're trying to build a zero to mastery database, which is going to contain courses. And we're going to store courses, we're going to store course information, and we're basically, in a very basic way, going to build that system. And an entity relationship diagram is what we would use to create that model. That is what we use to create a model. And it denotes entities. What is an entity? Well, an entity is nothing more than something that says what something is, right? When we look at storing, for instance, courses, we know that one of the entities we want to store is a course. We know that we're talking about courses. And so when we start thinking about this, we start thinking about modeling a database. And when we model a database, we have to define the entities that we want to store. An entity is a thing that we want to store. When we define that thing, we have to define what we want to store for that thing. So for a course, what we would want to store is a name, a description, a subject, and then we would want to store some feedback, for instance. That's what we would want to store for a course. And then, well, when we think about it, well, a course also has a subject. So we're going to have to store subjects for a course. You know, it may be IT related, it may be business related, it may have a different thing. And so when we think about subjects, we think about subjects as entities. And then, well, we need students. We need students to follow the course. So we'll have students, and students can be enrolled in a bunch of courses. Getting to this diagram is a whole different set of skills. It's an architecture skill. It's a skill that you will need in order to build out a diagram. It has less to do with actual SQL and more to do with conceptual thinking. And so when we look at this, you may be thinking, well, Mo, like, okay, you created this diagram, but how am I going to create one? And so we'll have an entire section on how to build up a diagram like this and what mental models you'll need to follow in order to be able to think about this more granularly. Basically, what we're trying to show you here is that there are ways to think about how to build a database. There are structures in place and ways of defining a way to formulate what a database should look like before you go ahead and create all the tables and all this stuff. Diagrams and architecture is vital to specifying what your database is going to look like and how it's going to be sound, how it's going to be something that, can withstand different changes. And when we look at this, when we look at, for instance, our entity relationship diagram, well, what we know is that we have primary keys and foreign keys. This is something we've seen. And what primary keys and foreign keys have in common is they say when something's unique, but they also say when a relationship is being formed, right? And what we see over here in this diagram is we have all of our entities: enrollment, student, course, subject, teacher, but we also have these weird lines here. And these weird lines are what we call crow's feet notation. And crow's feet notation is nothing more than trying to tell you what kind of relationship is being formed. Like if we look at student and enrollment, how do we read this? Did you randomly draw this line? No, I didn't randomly draw this line, I promise. What we did here is we decided to say, hey, one student can have 0 or more enrollments. So this denotes 1. So one student can have 0, that's why the circle is here, or more enrollments. And if we look at this, one course belongs to 1 or more enrollments, but an enrollment can only belong to one course. One specific enrollment can belong to one course. You can be enrolled as a student into multiple courses, but the enrollment itself can only belong to one course. You can be enrolled into multiple courses, but the concept of an enrollment can only belong to one specific course. So when a student enrolls into a course, a student is enrolling into a specific course, not multiple courses at the same time. A student can still have multiple enrollments and have multiple courses that he or she is enrolled into. But when we denote it like this, what we're trying to say is we're trying to map that relational model that we talked about way back in the beginning. This is how we get towards defining that relational model. And there are specific rules that you need to follow in order to build a diagram that follows that relational model. Now, with that said, what is important here and what is most important here is not to understand how to build up a diagram like this, but it is to understand the necessity of a diagram like this. A diagram like this, the architecture up front, makes it so that you can build a coherent database. And it's not to say that this database is the most spectacular database or it couldn't be made better. No, we're trying to give a good baseline here and explain a concept that is absolutely necessary when building out a database. Now, we've seen a lot of different sample databases so far, right? Lots and lots of sample databases. We have our employees database, we have our world database, we have all of these databases that we've been doing exercises against. And a lot of them do not follow the best practices. And when we look at when we're going to do this, when we're going to create a database, when we are going to create a data shape, we're going to try to follow as many of the best practices as possible. Now that we're modeling our own database, it's important to follow the common standards. We want to follow those common standards because we want to build something that when other people come in and look at, they're like, okay, yeah, this looks good. Everyone will always have an opinion. But when you follow common standards, it's much easier for other people to be able to come in and understand what's going on. And so let's talk about naming conventions. When we talk about naming conventions, when we talk about, for instance, table names, and when it comes to naming things in software is the hardest problem. It is. Different programming languages and different technologies have different conventions. Well, when it comes to table names must be singular. This is a common convention, and there are a lot of different rules for this, theoretical rules, database rules that come into play, and it's good to follow this common practice. We don't want to name our table students, because when we store data in that table, we're always storing one single student. When we talk about table names being singular, it's because when we read the relationship, we can read it in that way. Table names being singular is just a common practice. And then when we talk about naming conventions, columns must be lowercase with underscores. So when we name columns, a common convention in Postgres and other database languages is because it's case insensitive. You can store uppercase, lowercase. Storing columns in lowercase with underscores is a common practice so that you don't have to use, for instance, the quotation marks. You can just underscore, 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 and everything is easily accessible. So storing column names with lowercase and underscore is a common practice. Columns with mixed case are acceptable. You could do student and then ID with uppercase. They're acceptable. Columns with uppercase, unacceptable. Just a common convention, don't do columns with uppercase. You know, all these rules that I just told you, they're common practice, but at the end of the day, just be consistent and write down your rules. Those are the best practices I can give you.